In this lesson, we'll dive into the world of C expressions. We'll start by talking about the assignment operator, and then we'll go on to some other math operators after that. So an expression can be any combination of variables, constants, operators, and function calls. Right? Every expression has a type. That type is derived from the types of its component. Right? Down here, we're adding x plus y. The type of that expression would depend on the type of x and the type of y. So we'll go into some more concrete examples later. Right. But besides having a data type, every expression is going to evaluate to a numerical result as well. So suppose 3 was stored in x and 5 was stored in y. 3 plus 5, or x plus y, would evaluate to the expression 8. Right. So we'll talk about some of the greater than operator and the assignment operator after this. But first, let's talk about these operators. Right? What should you know about them? Well, their purpose, what do they do? So the plus sign is an operator. Right? Its purpose or its function is addition. Precedence, in what order does it perform its operations? So in what order does the plus sign perform its operations? Well, we'll learn the plus sign evaluates from left to right. And then we'll also learn what happens in these mixed expressions as well. The asterisk is the multiplication operation. The minus sign is the subtraction operation. And we will learn that multiplication is of higher precedence than subtraction. Really, C follows the rules that we know from math, right? In math, we would know that multiplication would occur before subtraction. So the way this expression is evaluated is the same as if we put parentheses around A times B and C times D. And when operators are of the same precedence, such as the multiplication here and the multiplication here, they evaluate, this one evaluates from left to right. So multiplication, A times B would be performed, then C times D is performed, and then the subtraction is performed. Right? And then the other thing, associativity, right? And that's what I'm talking about, either from right to left or left to right. So these operators, right, here's A minus B minus C. There's two subtraction signs. They both have the same level of precedence. So this subtraction operator associates from left to right, meaning A minus B is calculated first. That result is, or C is subtracted from that result. It's the same as this operation here. All right, we're going to start off then by talking about the assignment operator. Right? We've used then the single equal sign. This is the assignment operator. And the way it works is what's on the right-hand side has to be an expression, and it's always assigned to a memory location on the left, and it changes the contents of the memory location. Right? So we say that it has a side effect of changing what's stored in memory on the left-hand side. Right? And then we don't say x equals y, we say assign y to C. Right? So whatever's on the right-hand side is assigned to the memory location on the left. Right-hand side, RHS, assigned to left-hand side. Left-hand side has to be a memory location. Right-hand side is an expression. All right, so down here is an example. If I'm declaring x as an int here, and then I want to assign to it the value of 4 plus 5. Well, this expression is evaluated first. So 4 plus 5 is 9, and then 9 is actually assigned or stored in x's memory location. Let's go ahead and take a look at a coding example. All right, let me pop this up here. All right, here's some code. All I'm doing is declaring a variable named x. I've got a little printf statement here to show us when the program finishes. If we were to run this program, we would just see the message program finished display on the screen. If we run that, right, it's not a real interesting program. What I'd like to show you is I'm going to start using the debugger in some of these examples. I've made a code blocks console project, right? It's got this file, main.c. You can see that my project name here is expressions. I'm going to use a tool called the debugger. Well, I'm actually in debug space when I made my project. It goes there by default when I choose that space. Right? I am going to put the cursor here. I'm going to go to the debug menu. And I am going to choose Run to Cursor. Right? And what that does is it actually starts running all of the code up until the point where it reaches the cursor. So I left my cursor here at the start of this printout. meaning it ran all the code, started running my program, and all there was to run really was to go ahead and create a variable named x. Right. Now, unfortunately, it looks like that is not showing up in my locals definition because the compiler optimized it away. That was not very nice of the compiler. I wanted to show you that the value of x, but what I just did here in this watch window, I typed in x since it didn't show up as a local variable. It should have shown up, I'm running main, it should have shown up as local to main, and you can see it popped up a message optimized out. Right, the compiler tried to help me because I had a variable in my program that I wasn't using. Right, now I've got to change that so we can see what's going on. But right now I'm going to stop the debugger. That's the icon for debug continue. Here's the icon for stop debugger. All right, let's go ahead. And what I'd like to do is I'd like to assign some value to x. All right, let's assign 5 to x. And let's print out the value of x so that our compiler doesn't optimize it away. All right. And so I've got a new line here before x. All right. Actually, what I think I'll do, I'm just going to call this function called puts. Puts by default will write only string information, and it will always end everything with a new line character. If I do this, puts with an empty string, I should get a new line before the start of this, and then that'll make the string a little bit easier for you to read. So I'm going to put a comment here that says print blank line. All right, that's the purpose of that. And here we'll print the value of x. X is of type int, so I'm using %d to print out its value. All right, and so let me go ahead and rebuild this. All right, no warnings. All right, what I want to do is I'm going to put the cursor right here. Right. And another way I can get there is, besides going to the debug menu, I can right-click and say run to cursor. All right, so that starts running my program. So now I can see I've got x up here in memory. It's of type int. Right, actually it's showing up twice, probably because I put this in here. Right. I don't want to delete that out now. Let's leave it. All right, here's our x of type int. It just has the value of 62. We didn't assign the value of 62, right? This yellow triangle shows us it's waiting to run this code. Now, if you're following along with your debugger, and you don't happen to see the watch window, you'll need to go to debug, and then debugging windows, and if I turn off, my watch window goes away. If I go to debugging windows, and check watches, my menu comes back. It's now down here. All right, I can move things around, but it's fine right there. All right, so now I want to just execute one line of code. All right, so I go up here and I click on next line, or you can go to the debug menu and click on next line. And so we can see after this line of code executes, it actually stores the value of 5 in our variable x. All right, just going to hit next line. All right. So my console window has popped up as well too. Right, it's output my blank line, and if I hit next line, right, and when I do that, I close that. But now we can see, right, that it displayed x of 5. Right, I can finish this up if I wanted to, simply by hitting next line, right, and you can see it's here at the end. If I hit next line one more time, then my program should just about terminate. Right. All right, I'm going to hit stop debugger. All right, so you have to be in a project environment to do that. All right, we saw then that x was assigned the value of 5. It changed, this assignment operator changed the value stored in x. All right, let's just go ahead and initialize x equals 5 here, y equals 4. And now let's say that x is equal to y. We're going to assign the value stored in y, which is a 4, to x. Right. When we get done, we'll see that X's memory location changed, but Y's memory location did not change. So let's print out Y's value as well, too. All right, let me build this. All right. So I'm going to right-click, run the cursor. All right, I can now see, yeah. All right. I'm going to get rid of that extra X. All right, X has 5, right? We assign the value 5 to it. Y has 4. Right. So now if I hit next line, right, we'll see then that the value stored in Y, 4, is now also stored in X. Notice X is in red. Usually the variables that were changed by the last line that were executed show up in red in the code blocks debugger. Right. Similarly, I could just say debug continue so that it would finish running my program. Right. All right. So the point of that was to illustrate, 1, how to use the debugger. 2, that if we don't assign a value to X, as we saw previously, it had that value of 62, it has garbage until we actually assign a value. 3, in this case, X and Y both have known values. We saw that when we stored Y's value over 2X, when we assigned its value to X, that X's memory changed, but Y's memory did not change. And let's see, we can show one other thing with the assignment operator. All right. Let's show the value of an assignment expression. All right, in this example, then X is set to 0, I is set to 5, or assigned a value. Right. So you can see this printf statement is going to print out this text value of assigned expression X equals I is 5. So this %D, when we make this assignment here, what actually happens is the 5 is assigned to X. X's memory is overwritten. This expression returns the value of 5. So whatever was stored in I, or sorry, whatever this expression's value is on the right, is assigned to this on the left, and the whole then expression will evaluate to a 5, which is why the 5 is printed out here. So you always want to remember that when you make assignments, they do evaluate to some numerical value. All right. Let's see what else we got. Once in a while, you will see, chained assignment. So chained assignment means we just have several together. Well, the assignment operator associates from right to left. So technically what happens in this case, the 0 is assigned to K. So down here, this operation happens first. 0 is assigned to K. This whole expression evaluates to 0. So then 0 is assigned to J. That whole expression evaluates to 0, and then 0 is assigned to I. Right. Assignment happens to have the lowest level of precedence. That's why the expressions on the right-hand side of the assignment operator will be evaluated first, because it has the lowest level of precedence. Remember, it associates from right to left. And then remember, what goes on the left-hand side, or the L value in this case, must be an object stored in computer memory, not a constant or expression, right? So a variable name. So trying to assign I to the constant 43 is incorrect. Trying to assign J and using the negative sign to negate I is also incorrect. Trying to assign 0 to an expression on the left is correct as well. Incorrect as well. Right, so those are things you don't want to do. The compiler will generate errors. So the left-hand side always has to be a memory location. Okay. Now, sometimes people will mix assignment types, and this is not really good programming practice. So these examples are more or less to show you what will happen if you do that. Right. So F is a float, I is an int. So if I were to take this constant 72.99, F makes this as a floating point, constant instead of a double, and try to assign it to an integer, it's going to truncate then this 0.99. It doesn't round up, it truncates it, because I can only store the integer portion of this. Like I said, you want to watch data types. This isn't something you normally want to do. Just be aware of the consequences if you choose to do something like this. Similarly, technically this is an integer data type, 86. And if we assign it to the float on the right, well, what's stored in memory should be 86.0. So it promotes this to a float value of 86.0. Here's an example. I have a note here. This is not a good programming practice. Let's take a look. I is an int, f is a float. So here's this constant, 8.03. It's a floating point constant. Because we're assigning it to the integer, it's going to be truncated to 8. So this expression will evaluate to an 8, and then we'll see an 8 assigned to f. So in this, when you run this program, you will see 8 and 8 appear on the screen. Now in this example, 72.99 is a floating point constant. You're trying to assign it to a float, so there's no truncation. So f will get the value of 72.99. This whole expression evaluates to 72.99. It's assigned to I. Because I is an int, it's going to truncate the 0.99. I will get a value of 72. Like I said, if you found that confusing, that's fine. These are not things we normally do in programming. Once again, this is just an example to show you what chained assignment will do. We try to avoid chained assignment, right, as programmers. All right, in the next video, we'll go ahead and talk about the arithmetic operators.